So looking at the first problem on this side, we have a linear function for a number of years, and then we have an exponential function. So at year 0, there's 152 kids that like me. I know that's hard to believe, but this is a pretend story. What? And then, so if I follow this down, 4, 5, 6, 7, 8, I'm going to subtract by 30. So 152, 122, 92, 62, and 32. What would the function be representing this piece? We just kept subtracting 30. So what is the linear function? Negative 30x plus 150. Now, if you don't know how to write that by hand, you could always do stat edit, pick 2 points, and do linear regression. So negative 30x plus 152. What are the x values for which this function is valid? From, not 1, from 0 to 4. So it says that that pattern continues until year 4. So I'm going to write x equals 0 to 4. Should I include both 0 and 4? 0, yes. Do I have to include 4? It doesn't really matter. How come 4 doesn't matter? You have to include it in one of the two functions, but it doesn't matter which function. All right, so after year 4, it's going to increase by 50%. What do we multiply by in order to increase by 50%? 1.5. And the way to think about that is 100% plus 50% is 150% as a decimal, it's 1.5. So times by 1.5 and I get 48, 72, 108. That one I can't do in my head. What's 108 times 1.5? 162? Okay. So now I need to figure out what the exponential equation is. So we'll go into my stat, edit, and I have 432 and 548 plugged in there. Oops. So I'm going to do 0, which is exponential regression. And the equation is 6.32 times 1.5. So 6.32 times 1.5 to the x. When is that function valid? From 4, do I include 4? Well, no in this case, because I included it in the one above, so parenthesis. When does that function end? Whenever I stop teaching, right? And I don't know when that is, so we'll put infinity. So how many students liked Mr. White on years 3 and 9? Well, 3 is part of the chart at 62. How would I figure out 9? Just times by 1.5 again, or you could plug 9 into the equation. Either way. What do you get? So 162 times 1.5, which is 243. If I times by 1.5 again, what's the answer there? No, not 364.5. 364. Right. So when you're dealing with people, you always round down. Because we don't say, hey, look, it's 3/4 of a kid. We'll count them as a whole kid. There's no such thing. You're either a kid or you're not. You're either a person or you're not. But they're still counted as one person, right? You never round up. You always round down. Yeah. um, so how many students will there be in 10, 364? So let's look at the next problem. I opened a checking account 5 years ago. I put in 12,500, and I apologize. The graph is too small, and the chart is also too small. Apparently I wasn't thinking when I wrote this. Since that time, I spent 20% of the money each year. Today is always year 0. I took the remaining money out and placed it in a 4-year CD that earns 12.5%. When the CD runs out, I plan to take the money and spend $725 each year on a country club pass, which is weird because I haven't been golfing in years, but whatever. So, what is the first point in the chart? 12,500 during what year? Year -5. Okay? So, what am I going to multiply this 12,500 by? 0.8, a 20% loss. So -4, -3, -2, -1, 0, 1, 2, 3. And I'm just going to keep going. 4, 5, 6, 7. So 1250 times 0.8 is 1,000, and that's still, or 10,000. That's still off the chart. I missed a 0. So 10,000 times 0.8 times 0.8. So 8,000, 6,400. If I do one more, that will put me at year -1, 5120. And one more puts me at 4096. Well, do I need to use my stats calc in order to figure out what this equation is? What do I need to know in an exponential equation? I need to know the percent, which is 0.8, and I also need to know year 0. Do I know year 0? I do. It's 4096. So this equation is 4096 times 0.8 to the x. If you don't understand how to do that, just plug 2 points into your stat and then find the exponential regression, and it will give you that equation. What are the points, the x values, for which this function is valid? Not negative infinity. From -5 to 0. Do I include -5? Yes. Do I include 0? It doesn't matter. You can include it where you like. So from -5, I'll include it with 0. Okay? Then what happens? I'm going to increase by 12.5. How do I increase by 12.5%? Well, it's 100% plus 12.5%, 12.5%. So that's 112.5%. What does that look like as a decimal? 1.125. So I'm going to times this by 1.125. That's year 1 times 1.125. That's year 2 times 1.125. 3. I better write these down. So 4608, 5184, 5832, and one more is 6561. So this is an exponential equation. What is it going to look like? Or what's the equation going to be? What is my b value? So, have we forgotten how to do this? So we're trying to find b times m to the x. B is year 0. Do I know year 0? 4096. So 4096 times 1.125 to the x. When is that equation valid? When x equals... Are you confused, Aubrey? Well, when... what are the x values for that function? From 0 to 4. So that equation only counts from 0 to 4. Do I include 0? No, because I included it in the last one. Do I include 4? If you want to, you can. You just have to include it in one or the other. So 0, parenthesis, 4, and I'll put a bracket. Okay? So what happens after that? When the CD runs out, I plan to spend $725 each year on a country club pass. So I'm going to subtract 725. I get 5836. I do it again. I get 5111. How should I figure out the equation for this? Do I know year 0? What is it? It's not 4096. No, 6561 is year 4. So I need to backtrack 4 years to find year 0, or you can just use your stat. Edit. So year 4 and year 5. Come on. And then I just need to plug in 6561 and 5836. And then what type of regression do I want to do? Exponential, quadratic, or linear? Linear, how come? I'm spending the same amount every year, so linear regression. So the equation is negative 725x plus 9461. Now, when is that equation going to be valid? From 4 until I run out of money, right? Because once I run out of money, I can't buy any more passes. So how am I going to figure out when I run out of money? And that would tell you, okay, you could do it that way. Or what I would recommend, that if you did it that way, you would figure out how many more years you had. But I want the actual year that it's going to stop. So I'm going to say negative 725x plus 9461. I want to know when that equals 0. So I add 725x. I get 9461 equals 725x. So 9461 divided by 725. So, does 13 count or not? Well, let's look at the graph. So if I were to graph this, excuse me, the first part of the graph, this one here, is going to look like this. So that's where I'm losing 20%. The second part of the graph, I'm going to be gaining a little bit until year 4, at which point I have 6,500. So it's going to look like this. And then after that, it's going to be linear, and it's going to go down, and it's going to almost hit 13. It's going to cross the x-axis at 13.5, 13.04. So the first question underneath says, when will I no longer be able to buy a country club pass? At 13. At 13, I'll only have, I don't know, like $36. So when I reach year 13, can I buy a pass for that year? No. But can I use last year's pass all the way up till 13? Yes. So what is the domain on the linear function? It starts at 4, and it ends at 13, and I don't include 13 because I cannot buy a pass for 13. I don't have enough money. All right, how many country club passes will I be able to buy? How many years will I be able to golf? Well, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 9 times. I can buy 9 passes. At 10th pass, I don't have enough money. When did I have the greatest amount of money? 5 years ago. How much did I have 2 years ago? You can look at the chart. How much will I have 8 years from now? How will you figure that out? Eight in to this equation. So negative 725 x, times 8 plus 9461. So that's how much money. Is that the wrong number? Okay, turn the page over. So, we're going to graph these. This is kind of a review from what we did yesterday. In order to graph a piecewise function, you need to know what each of the individual graphs looks like. If you don't know how to graph them by hand, just plug them into your calculator, and then you can see what they look like. So the first one is an up parabola that touches -1. So that is this graph. The second one is linear. It starts at -1 and it goes up $2 every year. So that's this graph. And the third one, what does that look like? It's a straight line at 3. Okay? So now we just have to decide how much of each graph belongs in our piecewise function. Okay? So the first domain break is at 0. So if I draw a vertical line at 0 on the first graph, this is what I'm including, and that's what I'm throwing away. Is that endpoint open or closed? It's closed because it says equal to. And what if I don't know where this happens? How do I figure it out? I just plug in the domain, and I get -1. So I have a closed circle at -1 with the left side of a parabola. Okay? For the second one, the domain says from 0 to 5. So this is the portion I'm going to keep. And I need to know what those endpoints are. So I plug 0 in, and I get -1, which just so happens to be the point that's already there. So is that an open or a closed? It's an open on top of a closed, so which one wins? The closed wins. All right? And I plug in 5 to find the other endpoint, and I get 5 comma 9. So I go over to 5 up to 9. Is that open or closed? Closed because it's less than or equal to 5. Does anybody not get that? And it's linear, so it's just a straight line. And for this one, I'm just going to go over to 5 and include that part of the graph. Is the endpoint open or closed? Look again. Open. So I go over 1, 2, 3, 4, 5, and I go up 3, open circle, the line going over. Okay? Now, let me show you how to graph that on your calculator. There is a way to do it. What you do is you put parentheses around the function, and then you put parentheses around the domain. But if the domain is compound, meaning it's like 0 less than or equal to x less than or equal to 5, you can't put that as one domain. You have to split it into 2. So for this second one, you'd have parenthesis 2x minus 1 parenthesis, and then 0 less than x parenthesis, and x less than or equal to 5. So to find the inequalities, above the math button you see test. So second test, and all the inequalities you need are right there. So to graph that, this is what it should look like. So you just type in parentheses, the function goes in the middle, then parentheses x less than or equal to 0 parentheses. For the second one, you need to split that inequality into 2 inequalities. So it should look like 0 less than or equal to x and x less than or equal to 5. So when you plug those in and graph it, that's what it looks like. Now, go ahead and do it. Some of you are going to get a little bit of a mistake on your graph. So if you have this funny line, yeah, yours is, you didn't finish though. So graph the other ones. So you just put the function in parentheses and put the domain in parentheses. I'm confused. What do you mean? Yeah, then just do the next one. Let me see. Okay, so put the rest of them in. Anybody having trouble with that? Second math. Okay, so you can't do this all as one. You have to split it. So you do that, and then you do x, whatever it is, less than or equal to 5. So if your calculator does this, it will probably always do this. For some reason, the calculator takes the endpoint and connects it to the x-axis. And I don't know how to, I don't think there's any way to fix that. So if your calculator draws that line, just ignore it. It's not really there. And it'll probably do it on every inequality, every piecewise function that you create. All right, so let me take a look at yours. So if you ever have a syntax error, you go to, and you have x less than or equal to nothing. Okay, so your job is to graph, your homework tonight is to graph that bottom function.